What's up, 8th grade? Mr. Agnos here, and today we're going to be talking about something called initial value. So you can see the word initial value right here, and don't be scared by this word. You already know what this word means. So remember, I always talk about math being a language. So initial value is just a synonym, right? Synonym is two words that mean the same thing. It's a synonym for the Y-intercept. Okay. Y-intercept is a very mathematical term, right? It's the point where the line crosses the y-axis. Initial value would be, hey, we're actually measuring something. We're measuring how tall a tree is. So maybe I have a graph, right, that looks like this. And on the y-axis, we're measuring the height of this tree. And on the x-axis, we're measuring over years. Okay, now trees in general get taller, all right? So we might have a line that looks something like this. Well, the initial value is just the y-intercept. It's this point right here, and I'm just going to make up a number. Maybe it's 10. And what that means is, hey, the tree, when we started measuring, the tree was 10 feet tall, right? So if you were going to say this very mathematically, you would say, well, the y-intercept was 10. Right, and that says, hey, at year 0, when we started measuring, our initial measurement, it was 10 feet tall, and then every year after that, you know, we're going to measure, and the tree is going to get taller. Well, initial value is sort of a more conversational way of saying that. It's the starting point, right? So initial value is just the y-intercept. So question 1 says, find the initial value of the linear function, and they give us a linear function right here. I'll go ahead and rewrite it bigger. Now, remember, all linear functions can be written the same way. I know it's been a while since we've been away for winter break, but all linear functions can be written in the form y equals mx plus b, where m is our slope, and b is the y-intercept. Well, remember that y-intercept is just a synonym for initial value. So I look at my equation here. There's my y-intercept, 8, right? So my initial value is 8. Got it. Okay, so I'll go ahead and just maybe apply this equation to my old tree here. I'm going to erase the 10 and make that an 8. So maybe this equation represents how this tree is growing over time. So initially the tree was 8 feet tall, and after 1 year, it would have grown 3 feet, right? My slope is 3. So after 1 year, right, maybe we're now at a height of 11. And after 2 years, maybe we're now at a height of 14, and so on. So over here, we are jumping by 3 every time. Right, we're going up by 3 because it's growing 3 feet per year, and our initial value, right, was the starting point. Right, there's our initial value right there. So really, we're taking a concept that we already know, giving it a synonym, some new vocabulary. Remember, math is a language. You're learning how to be fluent in a language so that you can speak it fluently and understand it when you see it in the future. All right, next question we're going to take a look at is number 4. Number 4, they give us a graph. So it's just it's information. It's just given to us in a different way. This one says find the rate of change and initial value. All right. So the first thing we have to recall is that rate of change, that means slope. And initial value, as we just learned, means the y-intercept. So they're just asking us to find the slope and the y-intercept of this line. So again, that is review. We're just using the new vocabulary that we learned in this unit. M is always my slope. B is always my y-intercept. And remember, y-intercept means initial value. I always start with B just because it's the easiest. My y-intercept is right here at 3. So my initial value is 3. All right. What about the slope? Okay. So remember to find the slope. I'm going to start at, excuse me, I need a starting point and an ending point. So I'm going to start at my y-intercept, and I'm going to move down the line until I get to a point where it perfectly intersects the crosshairs right here. So now I have a starting point and an ending point. And let's go ahead and calculate the rise and the run. All right, my rise, I have to go down 1, 2, 3 units. Because I went down, that's a -3. And I have to go to the right 8 units, right? I'm at 0 and I have to go over to 8. So that's easy. That's 8. So my slope is, my rate of change, right, which is the same as slope, is -3 over 8. So let's go ahead and write this. The rate of change is -3 over 8. Got it. And the initial value is 3. Got it. Okay, so again, that's pretty much review. We're just using this new vocabulary. All right, the last question I'm going to go over is number 5. Number 5 is a word problem, but it kind of demonstrates why we use this term initial value. It says the graph models the height h in meters of a hot air balloon t minutes after beginning to descend. How high was the balloon when it began its descent? All right, so hot air balloons are those big balloons with the baskets underneath them. All right, so you have a big balloon here, and often they're like pretty colors. So you'll have like a nice red section of the balloon. This is what, when Dorothy took to Oz in The Wizard of Oz, right? Or how she got home, I mean. It's important to have a beautiful hot air balloon here. You guys know I'm an amazing artist, right? This is all on the fly, right? So here is the balloon part, and then it usually has, some ropes come down here, and then we have a basket. There's my basket, and then we have Dorothy. I'm making Dorothy. There she is. There's Dorothy inside the basket. All right, so this is already in the air, right? How high was the balloon when it began to descend? So it's already in the air, right? Maybe the ground, here's some green grass. So here's the ground right here. The balloon is already in the air, right? And now it's going to start to come down, right? It's going to start to gradually come down until it lands safely on the ground. So we want to know, well, what was this height? When we started measuring, what was the initial value of the balloon? How high did it get before it started to come down? And they give us this graph here. And so the point we're looking for is the y-intercept. This graph says the height of the balloon, and at time, we're measuring time here in minutes, at time 0, the balloon, and we're measuring height in meters, the balloon was 65 meters. That's pretty high. I know we don't, you guys maybe aren't used to metric system. A meter is approximately 3 feet. It's a little bit more than 3 feet. So that's 195. So this is almost 200 feet. We'll just say approximately 200 feet off the ground. But our balloon had an initial value of 65 meters. That's how high it got. And I'll even put approximately 195 feet. And then it started to descend until she landed safely on the ground. So that's all it's asking you to do is, hey, what was our first measurement? And your first measurement for whatever it is, that's your initial value. So the balloon was 65 meters high when it began its descent. Okay, so that's it. Initial value is a synonym for y-intercept. So sometimes they give you a very mathy example. You're just looking for the y-intercept. Sometimes they give you an example like the balloon. You're looking for that first measurement, right? That initial measurement. When we first took a measurement, what was that value? And then we look at how it changes from that point moving forward, right? My tree got taller, the balloon got lower. So that depends on the rate of change. Initial value is a synonym for y-intercept. All right, guys, hopefully this was helpful, and I'll see you in class.